Okay, now we can talk about stuff. Overview is like, as I said, what was talk to the guys a little bit before you came back. So why is resilience important, especially microservices? What are the best practices for designing resilient distributed architectures? And how do you test those applications? Okay, let's do it a bit quicker. Why resilience? So this is a nice comic. Not really, I don't think it's the best comic. You can best comes back here. I believe you would say, hey, he needs his Lego system, or he needs some, doesn't need technical depth or whatever. It's kind of quite a funny anyway. Have you read it? Yeah. So in general, Murphy's Law, anything that can possibly go wrong does, shorter version. And this is from a guy called Microservices. He's a former peddler of extraction, whatever that means. It's a Ruby profile. And he said resilience is an imperative. Our software runs on the truly dismantled computers we call data centers. Besides being, I don't know how to pronounce it, high-nosely complex, who knows, complex, they are unreliable and prone to post-operator error. So basically, computers are complex. Have you seen that last week? Who saw that? Yeah, it's horrible. Even Google couldn't access my calendar for often. And suddenly you don't know what to do. So what do we want? So we want to have microservices to be like those guys. With some Buddhas here, all relaxed, sunny here, and still some dragon here. You know that server, it's always down. So in general, what are the potential problems with microservices? So like the first one is performance. We know that. The microservice Meetup is 5 years old, so we know that. Correctness, it's hard to prove that distributed systems are correct. Monitoring, it's a lot easier to monitor and monitor. You just plug in whatever software. Debugging is hard, but efficiency is hard. Yeah, because networks, etc. Security is hard, but the last two points what we are going to talk today is operability and resilience. So, and resilience is hard because we have at least one of those. I imagine you guys you didn't start your company, so you have some guys did. So there's probably software you didn't write, there's hardware you cannot touch, and a network that you cannot configure. And then the system needs to run. And you have to fix something. You're on call and it's falling o'clock in the morning. And all the stuff breaks in new and surprising ways. And your customers shouldn't notice that. So let's get to some best practices, how to sprint resilience stuff, how to keep your customers happy, boss happy, get some sleep at night. So a very simple example. Let's consider this. We've got an invoice service, service that creates PDFs for customer proposals or whatever, or just invoices. And you've got exchange rate servers because your customers trading in dollar, euros, pounds, this is yen, this is ruble. I think the Chinese signs the same. And suddenly the connection is disrupted. Okay, but you still have to print invoices. What do you do now? A very old paradigm is defensive programming. I'll show you a quick code. I hope you can read in the back. And I'm going to ask you what's wrong with that code. Don't say it's true. Just don't say that. There's inherently something wrong with the code. Anybody just try to figure out what it does? I'll give you a couple of seconds.
It's easier than the response.
Okay, has anybody figured out what the code does?
Keeps retrying, backsolve, then keeps retrying.
Okay. So basically what it does, it has some strategy to deal with the downtime of Exchange server, because the Exchange server is unreliable, you know that. So what it does, while the retry count is currently at 0, is smaller than next retries, 7, to get a response called exchange rate somehow. If there isn't a response there, cache the response, because you don't want to frequently call the server, and then you return the response. If the response doesn't happen, you skip for a wait time. It might be a function, it might be something else. And then you have the wait time increased with the retry count, and then you increase the retry count. And if that loop fails for 7 times, we just return the cache rates if there are any cache rates present. And if everything fails, we just return rates in error and say, hey, could not match exchange rates. What's wrong with the code?
What's the thread?
Sorry?
Sweeps the thread. What's the thread?
Yes, but it can be like an extra thread, so you can have a fork through the threads, something like that. Yeah, but still it's a bit.
Maybe one more question, why we try 7 times? Maybe we have this already in cache. Try once?
Yeah, but still, but that's the point. So why does the function call it 7 times? Yes, might be 5 times, maybe 3 times. What else is wrong with that?
The logging doesn't happen at all. At this point, we don't know what the problem is. It doesn't have to be that the response is not there, but if you have something of the output changed or this rate, I don't know what happened.
Okay, so there's no logging. You don't know if something fails, what's going on.
One more thing, like if the response is, we don't know what the response could be like, it's giving a proper response, but the response is error response. This thing,
Yeah.
For example, yeah, but still code. For example, if it doesn't get a successful response, it just.
We don't log anything here, and we don't fully control of this procedure because it's everything is monolithic in one place. The logic together with the retries and with the cache.
But one thing is like, where would this line of code be? Is it like in a controller? Is it like in a business object? Or whatever? Where do you think it is?
If this thing fails, your cache rates are gone. It's in memory.
Yeah, it depends, but the cached rates can be a cached server, can be a Redis server.
If you write this and
So
you should consider that it could fail.
But the one point is, like, you've got a business logic, or a controller or service, something like that. Why does your business logic need to know all these things? You need to get a cache, you need to get an exchange rate, nothing else. You don't want to deal with it because you don't know how many retries, what's sensitive wait time, how to increase the wait time, to increase it linearly, to exponentially, because it's a Kubernetes server, and you don't know if somebody unplugged it or whatever. So this a typical code smells it's not the job of the business logic or your code to know the number of retries, the increased wait period, the caching strategy, if there's caching at all, because sometimes you need the live because the results, because it's important. If there's a higher inflation, you need the milliseconds. Otherwise, your business might lose a couple of millions in an hour. Logging is also a good thought, but logging is something might be good in business logic and not. Yeah.
But I have a quick question. Why do we think that this is the business logic? Because we don't do anything with the exchange rates. All the logic was behind the equations to retrieve the rates, but we don't do anything here with the rates. No business logic related to exchange rates in this method.
But where do you think that's logic?
Why do you think that?
It's like, for example, you've got an invoice service.
No, I understand.
We've got an invoice service, and this service has this function. Why does the invoice service need to know these strategies? So at first it looks good because cool, somebody thought about retries, somebody thought about increasing that, waiting periods, whatever, but it's not a point that needs to be in your logic. And also like, what about request peaks? Do you don't know what it works? You don't need to, sometimes there's also fallbacks where you call out different services, you've got some profiting mechanism, you've got a prioritization, etc. It's not part of business logic. Or like the timeout thresholds. What is a reasonable timeout? And so what to do? A very simple approach is like have a shared service object for all your services that needs to deal with Exchange server. Not the Microservice Exchange server, the other Exchange server. Or might be as well with Exchange server. You can work with job queues, and the job queues has a little bit more reasonable logic in there, like retries, etc. There are pretty good solutions out there. Or you apply some patterns, like the bestseller pattern, what I'm going to show you later, or use some tools, for example, Finagle or was both merged out of Twitter, not surprisingly. Okay, a little bit of theory. Who's heard of a reactive manifesto? One, two. Yeah, most of you. So it's kind of old. You can find it at reactivemanifesto.org. It has some very basic principles, and it's actually not that practical or handy, but it's important to know about them. So the reactive system says the system stays responsive in the face of failure. This applies not only to highly available mission critical systems. Any system that is not a cylinder will be responsive after failure. And how does the manifesto tackle that? There are basically 4 paradigms behind that. First one is delegation, second one is replication, fourth is containment, and the third is containment, and the fourth is isolation. So what the slides are going to be on the project. I'm going to share them in the speaker status. Okay, so the delegation. Yeah, usual stuff that comes like that. So basically, delegation is if a task is like busy or something, it's not working. Delegates just the task to another component, and the task is executed in a different context. There can be even on the same server, but most likely it's a network node, a different network node, where you, for example, have a cluster service. So that's just principles. It's not in practice. In practice, you probably have a load balance or something. Next one is replication. This is basically the same. If can also, what's really cool about that is you might ask different server in parallel, and if you're really performance needy, you might just take the quickest answer. So, okay, just continue. And the fourth one is kind of obvious with nowadays modern microservices, Kubernetes, etc. Where you simply have clusters and they run in isolation, you have certain boundaries, and the microservices well cut, and isolated, etc. in theory. So this one is not that exciting, you know, but we should hear about that. Just before we go into patterns, some general basic tools for preparing resilience. You need a lot of logging, because if something happens, it might be a month ago, you need to, at least tail or a grab to do some log files. If you've got a cool solution like Elasticsearch or something like that, then it might be easier. You need a decent monitoring, because if there's something CPU is running wild or you don't have enough RAM, you need to figure out what's going on. You need to do basic integration testing, obviously, and you need system testing, running it in staging environments, or at least in some certain canary environment where you test the stuff. And as a tip for service design, cluster your services into use cases. For example, if a marketing newsletter doesn't go out, who cares? Yeah, your marketing department, but still your CEO won't hire you. But if you lose like 10,000 orders, your CEO might think, well, not so good. So you need to think about the service levels agreements of the services, and also think about where do you put time in. Time is limited, it's tough. Backlog is growing and growing, but you have to think about that. So make a list of the services which are more important for your business, and then think about the challenges. So this is a response time. For example, Amazon had conducted some studies on how orders increased or decreased depending on response time. If it's lower, or even in Munich, I don't know. Some of you guys might work in online jobs, you know that. Are there any potential peaks to expect? What do I do with that? If there are data-intensive services, think about network bandwidth, think about CPU, GPU, I/O rights. Do I need an SSD in the server? Do I need more RAM? Whatever. Or if you have Elasticsearch, for example, goes through the scene, and the button of the scene needs fast I/O rights. Let's start with patterns. It's a little bit hard. Cheers, everybody. This is a very basic pattern. Everybody knows it. So source, the most important part is that part. It's called trans desk. That's, I guess, Apple machine there. Yeah, that's here. I don't know. I think the guy doesn't like monolithy. That's pretty so this is basically the pattern you're all going to see, but it's not something you want. So, what can you do against that? So, for example, we talked about the Exchange server before. How do you have your application shielded from that horrible service outside? It can be a web service, it can be an Exchange service, it can be just a newsletter service, whatever. An email, Sanctuary, for example, or the marketing department decided to use how's it called, Typeform. And Typeform is a horrible API, I can tell you. If you're accessing that directly through a remote service through your application, it's going to fail. Most likely, it's a lot of times. So actually, so there's a link down here at the Microsoft Azure Live 3, but Azure, we can say what you want about Azure, but we've got good technical writers. So the library is really good. you want to look at that. So the principle behind the episode pattern is it deals all with the issues we had before. It deals with retries. It deals with circuit breaking. Everybody knows what circuit breaking is? Who knows what circuit breaking is? And who doesn't? Okay, basically it deals, for example, if you make a request to a remote server and the remote server doesn't answer or whatever, it just cuts the connection and resources get freed. For example, if you have a crawler in the internet, that happens a lot because HTTP servers are unresponsive, you need to deal with that. And when Ambassador does the monitoring stuff for you, it says, okay, how is it slow, is it not slow, and it also can deal with security. So you don't need to supply the credentials of remote service to every application. Like this one. I know it's not that exciting, but it's a tenor. There's another similar layer because sometimes you don't have to, you're not dealing with an external system, but you've got a legacy system, and you've got this cool subsystem A with your microservices, with your isolated databases, everything is covered well, but there's still this InformixDB from 1994, and you need to access it. So what do? You make an anti-corruption layer. It's basically an API wrapper, or it's kind of the state. So subsystem B, and we have Microservices to that. So I guess for a lot of you guys, nothing that new, but some guys who saw it first time. I think it's useful. There's another thing like message queues. Yeah, I'm not going to ask all of you for the concepts if you know. But this is also very important. Message queue. So basically, we've got a producer. So some application says, okay, a guy orders something. You put that in a topic, like the order queue, and then in the order topic, and then you've got different queues that get accessed. Like this one is interested in sending out a newsletter. This one is interested in informing some dashboard or whatever. So like a red ping. Or this one, sorry. This one is just something that deals with logistics, and you can have multiple consumers. The cool part of it is the producer doesn't know about the consumers, and the consumers doesn't not know about the producer. You can scale the broker really cool, for example, routing queue, or you even can work with a little bit more elaborate stuff like Kafka or also Azure. I've got so many examples, but my speakers are not there. But Google, Azure, etc., they all have a native cloud. And again, it leads to resilience. That's really hard. And another exciting pattern is, so if you're talking about, for example, you've got a more complex transaction. So like step by step, for example, in a SAS, software as a service online shop, somebody orders like your total awesome new finance software. So what happens? First part, a user registers. Then a user requires a package, says, okay, the premium package with the fancy bells is something that I want. Then he chooses a plan, or she chooses a plan, like monthly or whatever, and a credit card plan, how to do a pay with Visa or whatever, PayPal. And then the payment is issued, and the confirmation is sent. Okay. But what happens when something goes wrong here? What would you do? Anybody got an idea? So like, for example, here the guy cancels the payment. What do you do now?
So it's like either the compensating transaction, which removes the whatever you populated with the databases or.
So what would you do if you have all the steps in one monolith? What would you do?
Yeah, like the second way is XA transaction.
So like when you do a rollback, you put in your transactions. You should be careful how much you put in one transaction. Quite a simple. The database know how to do the rollbacks. But in a distributed environment, what do you do? So, behind that, a user is creating a database. Some emails got sent to the marketing department. Here are some packages linked to the users as a data, etc. And here he suddenly decides, no, I don't want that. Okay, so the proposed solution or the commonly used solution is have a compensating protection pattern. So like if you go in the right, okay, what can you do to if the email confirmation already got sent and the guy decides, no, I don't want it. You need to compensate all of that. But here, yay, that's what it is first. So like for each operation, in each steps you need some undo stuff. And here, for example, it's send cancellation email. For the issue, if a payment already happened, you can either cancel the payment with your service provider, or you can trigger a refund. For the choose plan, is delete the plan installation, and delete package installation, etc. The point is here, you need to define for each of these steps in each service what can I do to cancel my last step. If everything fails here, something needs here. Okay, let's come to some Microservice and the patterns. Oh, it's really bad, actually, so low. Okay, let's talk about the microlift. So like everything depends on everything else. You shouldn't do that. Like for the architecture with brands does, you shouldn't do that. The more the merrier. Too much of everything is bad. There's a communication overhead, it gets too complex. Most likely your server instances are not cut in that way that reflects your domain or different domains. It might reflect because you've got some Scala guy who wants to work on everything, but flying blind is always frequency seen pattern. You don't do logging correctly, and you don't do remote monitoring. And also the pride and the wrath of distributed services, yeah, it's just going to work out. It works on my computer. In general, so some of you guys have a computer science degree. If you don't know this pattern, I'm really disappointed. So it goes back to the 70s, from late 60s to right now, especially Dijkstra is one of the guys. There are so many stories from former Siemens colleagues of mine who told me about Dijkstra. You know Dijkstra?
Of course.
Everybody knows Dijkstra? He's a
Semaphores.
Dijkstra is more or less a pioneer with graph algorithms. He's mathematicians from Holland, or Netherlands. And there's so many stories where he had some peers and explained to some students of him at the party how to do graph algorithms. Cool guy. And like he formed that one, suppression of concerns. What is the point of the separation of concerns? If you cut your stuff in the right domains, you can enable change improvements. If you cut it right, you need to get different departments involved, different people, etc. If you have too much information exposed, you cannot change it. So paradigm is information hiding. You don't show what's really going on. You have a limited API. You do loose coupling. So like with queues, you just try to keep your services separated as possible. And this is, yeah, not from Deutschland, but the format. But fail fast. Everybody I've seen so many programs that tried to figure out every exception, everything else, and deal with it. Don't deal with it. Just break. If it doesn't break, in the test it won't break, in production it won't break, and at some point you get just some random results, and nobody's happy. Going to be happy with that. And then suddenly a company has a business report, and the numbers are wrong. That's not good. But you might violate. Don't repeat yourself. For cohesion, like in Microservices, of course you've got duplicate code. You have duplicate databases. You don't do normalization of the data like frequency. Who cares? We've got so many servers, we've got so many CPUs, who cares? We've got continuous integration, you can do that. And cohesion, being more consistent, more coherent, who cares? But do violate. If it ain't broke, don't fix it. Work on your stuff. Break it. And that is why we're coming to testing one case. And you have to figure out where it breaks, how it breaks. Let's start with a tweet from Pragmatic. I don't know if you guys know the tweet. What's famous? So a QA engineer walks into a bar. He orders a beer. Orders 0 beers. Orders 19,99999 beers. Orders Lissa. Orders -1 beers. Orders week. And then a few versus a real customer walks. Where's the ball? And the ball bursts in flames, killing everyone. Yeah, that's why you should do case testing. It's a little bit of theory again. Case engineering is a discipline of experimenting with a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Yeah, because you cannot test everything, you cannot figure out everything. Like the QA guy was recently was decent guy, but he didn't figure out those. Has anybody heard of that framework? Who has? Back or here? Do you know how to pronounce it? Yeah, but it's Ken Evan. It's a Welsh word that means horned, habit, acquainted, accustomed, familiar. And it's it's a very simple framework, also used in soft sciences, social sciences, etc. to define complexity. So there are 4 quadrants. On the bottom right, you've got things that are obvious, so-called known nodes. For example, if you divide to 0, it's going to crash. Most likely. Or if you interrupt the TCP/IP connection, yeah, it's going to be interrupted. And then there are complicated stuff, known unknowns. Okay, there might be something wrong with blah blah blah, but we don't know yet what's going to happen. Okay, interesting. And then there are stuff that is complex, with unknowns. So you don't know that you don't know something. And the last one is, if you get the right button, it's chaotic. It's something that's unknowable. Depending on, so you cannot put that much effort in it, simply can't find it out. How would you experiment with that? And that's sweet spot. That's something you want to test. Because we always know you can write a unit test, you can write an integration test for that, you know what's going to happen. The rest gets a little bit more complicated, but still this can be found out with some, it's going to be enough to. Does anybody have time for me?
9 past 8.
10 past 8, so we've got a couple minutes left. Cool. And the last one is, of course, things that is not specified, just here for completeness. So, like this nice lady in our Jones says, chaos doesn't cause problems, but we use them. That's why we're doing it. I couldn't find the original source, but it's quoted in so many talks and so many books, so it must be So in general, how do you tackle chaos engineering? First, you start with a hypothesis, what might go wrong in the system. So like in social science, what do you want to prove? Like, don't know, men with bald hair are smarter than guys with curly hairs. It's a hypothesis. You test it and then you figure out it's similar systems. You test, okay, it's going to break when I do this or that. Then you set up an experiment, how to test that, but you try not to impact users. Please do that, as long as I'm a customer. Then you minimize the blast radius, so try the smallest experiment first to learn something. Don't, for example, if you're working with AWS, don't just cut off a region completely. That's the first step. Try something a little bit less extreme, yeah. And the fourth time is run the experiment, monitor the results, in the system behave carefully, then analyze the stuff, what happened, if everything worked fine, cool. Something didn't work as expected, you found a bug. So like in the first case, if everything worked fine, just increase your case radius a little bit and try it again. And the sixth step is fix it, if something got wrong, and retry it. So, as you know, we are agile guys, we love circles. Follow that hypothesis, set up experiment, run experiment, analysis, but do not forget blast radius, and do not forget to fix it. And failure injection, like if you want to try something, why do you do that? You can do that at an application level, you can do that in a host area, like just shut down some hosts, turn off Brand's desktop PC. You can do resource attacks, like just starve your servers. You can do network attacks, like for example Chrome has built in, just do some throttling, do some latencies, do some dependencies, for example with DNS servers. I had some crazy experience with Azure here, I fixed that. And then you can do, for example, region attacks. What's the okay, and there are some examples for what you can test. This is from a cool book from O'Reilly. The link is down there. I think the type is Case Engineering. It's pretty good. If you're interested, like, have a look at that. For example, like, who of you guys use Elasticsearch? Yes. Okay, you know when Elasticsearch maxes out CPUs, most likely it's RAM, but CPUs is something like that, you can try that. Another thing is time travel. Just, okay, you're depending on time zones, you're depending on like synchronizations, on does the system time tell me the correct time? Does the synchronization work? Servers are not always track. Then you can simulate a failure of an entire region or data center. That's like the hot stuff. For example, if you're working with Kafka or with RabbitMQ, you just can delete topics or queues or whatever to just recreate an issue that occurred in production. Because the most important marketing letter that the CEO signed himself didn't go out. You have to figure out why. And for example, you can also do a injection matrices between services for a certain percentage or predetermined period of time. So just to give an idea, just go a little bit quicker. Or you can also do a function-based chaos. You can do a runtime injection. Scripting languages is kind of easy. With Java, we just interfere with bytecode. Yeah, just causing random exception. And then you figure out, okay, my developers are really good, but they're not perfect. As I am, for example. You can also do nice stuff with, if you have a bare metal server, you can just play with drivers and emulate I/O errors and just figure out what's going on. So it's always depending on what you're trying to test, what's your hypothesis. What do I need to test? What is my business logic or something that's really critical I need to keep working? Depending on what you're trying to test, you might do something about these steps. As I told you, like this is the case engineering book with written here. It's really nice to read. Okay, it's getting really a bit hot in here. I'm just trying to wrap it a little bit up. So what are just some tools out there? This is like a list of tools. You might have to look at them yourself. Like Istio is quite popular case toolkit. I think it also works with Kubernetes. But some guys, if you might be experts here, same as QMonkey and Space. The idea is behind the case monkey from Netflix. Powerful Seal, for example, Kremlin. So it's just giving you a list of things because I think they're nice. And also, Netflix used to have a resilient army, but they duplicated it and they just have smaller packages. So and if you really have very simple tests, you can also work with some graphics scripts. So, it's really hard, and it's really tough stuff. So takeaway. First thing, be pragmatic. You're not Netflix, you're not Amazon. Your team is not 70 dedicated Ivy League software engineers. You don't have that. You don't have the money to test on 20,000 AWS machines. You won't get arguments to convince your CEO. I don't think so. Be pragmatic. So the thing is, again, know your most important services. Marketing newsletter might be important, but it's not. Your product checkout is important. Your web server is important. Because you need to consider the end user experience. And the end user experience is like the guy on the phone, it's like WhatsApp is down, he's going to try. If your TV server is down for half an hour, yeah, it might be not very important. Be defensive to failure. Everything is going to happen, just be defensive of it. Figure out and use tools in that. And one most important thing is that a lot of people forget, there was a talk of number 22, 24, 26, number 26 CTO, or I think it's not CTO anymore, what was it? Number 26 guy, yeah, this guy. He also gave a dedicated talk to that. To increase the importance of architecture that needs to change. And then it comes in the principle, separation of concerns, boost coupling, keep your information closed. And with that, you can also start with a Postgres database in a job queue. If you have got your job services isolated, you can later on migrate to RabbitMQ. You can switch to Kafka. You can do whatever you want. If you become Twitter, you can just implement your own 1.003 times faster service. But if you design that correctly, you know, so many companies will have got a legacy system from 90 something, where they have a legacy system that was designed to obsolete the other legacy system, and then another legacy system that wanted to make the obsolescence of before, and so on and so on. And then our company that has got 4 parallel legacy systems that basically doing the same thing, but they cannot get rid of them because they don't know what's going to happen. Don't do that. Architecture to change. Expect the worst and deal with it. You know the German show, quiz show, something like ORD, and the Pistol, they had an app, and suddenly you were surprised when the show is running, they've got traffic peaks. Yeah, we might have put up some auto-scaling of AWS.
Yeah, they were running on Google Cloud.
Yeah.
There was a talk about this some years ago.
But still, with auto-scaling or with nice design,
Yeah.
you can deal with 10 times, 100 times, 1,000 times the traffic, but just the system is already designed for. And then, what's the most simple solution for me? And last, play around with chaos. And most important thing, sorry, don't handle this much. Never forget about people. Ask other teams what's crucial for them. Talk with experts, what's really important, and bring them all on board. That was my talk. Woo! I think there's so many experienced guys here, just mingle and exchange.
Are we not going to do a Q&A?
Oh, Q&A. But I can do it later. We can do it in parallel.
In parallel to what? No. Now you're confusing me.
Yeah.
Just in case.
No, Q&A and then mingling.
Socializing, you mean? Mingling? Yes? Okay. So drinking beer, eating up the remaining pizza. Okay. So are you still alive?
Yes.
Oh, that's good. Okay. Do you have questions?
Yes.
Okay, then.
So first question, you mentioned the ambassador pattern and it resembles me to service mesh. And then you said that Istio is a tool for chaos engineering. And I think it's more like a service mesh and you can use it as a proxy for many, many purposes. And among these purposes is also doing some latency injection, circuit breaking and stuff, but I don't think the primary use of Istio is as a tool for chaos engineering.
No, it's not.
Do you agree?
I actually totally agree, but those tools are designed to enable that easily.
Yeah, of course.
If
But
you've got an
you can
AHI
do a lot more things.
yeah, of course.
Load balancing, for example, you did not mention.
Proxy, yeah, but so there are several load balancers proxies, but they're not designed for case.
Yeah.
And I totally believe Microsoft, for I don't know for what reason, just renamed the sidecar pattern to ambassador.
Okay, yeah.
So I believe it's exactly the same.
I also do so.
Yeah, basically it's the same pattern. Yeah.
So Netflix invented, I believe, the pattern. It's the
Yeah,
sidecar
okay,
pattern,
yes.
and somehow somebody feels ambassador is cooler than sidecar.
So things fail, and I might have a sidecar, or if you use Erlang OTP, then you have these supervisor processes. And so things fail, and you have a strategy to restart or deal with whatever errors. So what strategies do you choose, and how do you adapt these strategies in terms of your infrastructure changes, your environment changes? Are there any best practices for dealing with these error cases?
Yes, it depends what's going wrong. For example, actually the purpose of chaos engineering is to find out what's going to fail. And then it's crucial to have a decent logging and a decent monitoring. If something fails, you just log in the log files, you log in the monitoring, where the CPU spikes, where all the memory things happening. And then you figure out, okay, and what might happen? Was it just some bird servers? Was it bad software design? Was it, for example, the database was not correctly configured from a use case? There were indexes missing and stuff like that. It can be anything.
There's no simple answer.
This is the crucial part is to do the monitoring and do the logging. That's the usual part, especially with KS.
Okay.
And of course, there are some resilience patterns you already mentioned. So
having
an auto-scaling group survives Chaos Monkey easier than not having an auto-scaling group. So.
Of course, there are 20 to 50 to 100 patterns more that can do. But we only have a limited time.
You listed a lot of problems which can happen, RAM, EIO, etc. How do you convince your customer that you need time for this testing, that this scenario don't happen in the production environment?
Depends on what kind of customers. Also, that's more like soft skill. Do you remember when Twitter had this nice whale timeout? The 500 page was a whale. Sorry, we are under too much traffic, etc. Everybody loved that. Everybody said, okay, it's Twitter, we're nice guys. There's some really soft or nice whale. Why not? Then I figured it out. So like when Google had that file for free, it was crazy because I expected Google to be 99.99 to infinity reliable. And Google is that nearly. So for example, competition I had a little bit more downtime with them, but still expectation management and what kind of customers. Even as important as internal customers and extended customers. And as a expectation, if somebody expects a little bit of downtime, yeah, but just grab a cup of coffee, talk to some guys, go to the lake, whatever. Yeah. But if you promise like when you have 100% uptime and you're down, everybody says bing.
I believe also it's a thing of maturity and expectation. What you're trying to deal with.
Yeah,
if your cross-functional requirements are important around availability and those kind of things, it's a product feature.
Yeah, or if like a car, if like Tesla has a bug in its software, maybe the people might be not that happy about it. But if something unimportant like your Instagram feed doesn't work for a couple of minutes, then you might lose money and the teenagers might be disappointed, but still, I think they're not life dependent.
It would be great to know the best practices, how to deal with chaos if you have many microservices and you roll out the new features, and you need to make sure that microservices and all the features they are rolled out specifically in the specific order. You don't mix the order because one microservice could depend on another one, and you need to roll out the database changes. And how you can deal with that, just to don't break anything, or just to keep the order somehow tracked, or...
Yeah, it depends on design. For example, if you have real microservices, each microservices have a database or a data classes with them. So that stuff like different schemas won't happen. But still, like if you're doing the rollouts, it's highly recommended to do some canary testing or IP testing. Just put 5% of traffic, 10% certain user groups. Also, Facebook, for example, has some fancy stuff about certain regions, certain age groups, etc. that get rolled out. But it's also not very cool if you have some order what the services might be.
I believe it does not have anything to do with resilience, but it's a prerequisite if you do a microservice architecture that you decouple your deployment. So every piece of your infrastructure needs to be independent deployable, otherwise you have done something wrong.
Yes, that's true. They are independent by node and they could be deployed independently, but if you have the feature which touches 3 microservices,
So
microservices,
then you need to revise your toggling strategy so that you have but then that's totally not to do with resilience, but out of experience. Then I would go to a toggling service so that a feature toggle can cross service boundaries, or you forward the feature toggle in the request. So the toggle state is determined by the first service that is hit by request. The toggle state is forwarded to downstream services. So that's how I would solve it.
Or like you can just mark requests, HTTP requests, like put a header in it and say.
Yeah. So what you're trying to accomplish is that a feature toggle state needs to be the same for a request across multiple services.
When we have the feature, for example, one microservice uses the feature of another microservice, but what happens if we deploy one microservice first, and the second microservice will try to use the feature which is not available? Of course, we can monitor this, we can log everything, and we will see the error message, but the in best practices to keep the dependencies in order somehow to check it before.
I would just go the same route, deploy the downstream dependencies first and enable dependent features later.
Yeah,
so as with database changes, migrate your database first, migrate your service later.
Logically, we understand that we need to do this way, but sometimes developers they forget about the order, forget about this stuff.
Yeah, but then you can just do it the same way that you deploy something and the database is not running. You just have to wait until the database is running. For service A, it depends on service B, and that version, you just check if the service B version is there. If not, wait.
But we can talk about this in more detail. So more around resilience and chaos, so not about I have service dependencies. I'll come back to you.
What have been the issues you find out with chaos engineering which have been the most easiest to fix?
The issues that are most easiest to fix.
Some kind of issues you find out easier for networking to fix or for resilience, retry patterns.
Did you find any issues?
So which are the most easiest to convince my boss starting with chaos engineering?
Start with simple stuff. For example, what happens when a database server is down? Does your let's think about what's the most. Any of you guys have idea what?
Killing instances.
Yeah.
That's Chaos Monkey 101 on AWS, for example, or the other cloud providers. Instances just die, and Werner Vogels himself said everything breaks all the time. So killing instances regularly via Chaos Monkey should be the first chaos engineering you should introduce.
Or what you can do is like break network connections, like shut down your internal TNS server, so they can communicate with the same thing, or just certain key ranges.
So who is Chaos Monkey running? Or a similar thing. So who is killing in instances in production? Okay?
Test the resilience.
Okay, so for the audience, it was about 5 people who actually killed instances in production. You should do that. There is no reason. So we are currently not doing it, but I want to push for it. It's an eye opener. Yeah, it's an eye. Everything needs to be killed all the time. So when we rolled out, and this is an anecdote I told earlier, so I'm capturing your Q&A. But so when we rolled out our first Kafka cluster, we started very early to let the Chaos Monkey hit it, and then you get a stable Kafka cluster very soon. And the ultimate, yes, this is how you should do it. Kafka nodes will die anyway, so start with learning how to deal with it. Same for Zookeeper and all of those things. Kill instances. This is a fun exercise.
Isn't that what the guys in Chernobyl also did? In Chernobyl, what they tried to do little monkey testing, and then the
should do a test.
No.
How do you realize your ambassadors? So I really like this example about Istio. So in Istio you have this sidecar, and I was wondering, okay, that reminds me of this kind of aspect-oriented programming. So you got your encryption and mutual authentication, and you got your logging, and these are all different aspects that I might want to add to a remote function call. So how do you actually manage that? I haven't thought about it like that yet on Istio, but you might want to have some sort of configuration management and mixins or something like that for your sidecars and be able to configure that. Have you ever done something like this?
What do you mean, like secret stores or other configuration, or what do you mean?
So you want to configure your sidecars in different ways. Not every part will have the same sidecar configuration. So the logging will probably be different for different protocols that you're using. You will maybe want to use TLS in some cases, and others you won't. You will have a retry strategy for your remote call. So, and this easily gets complicated, and it sounds to me like you will have a configuration probably written down in source code for your sidecars, kind of that you can push to your cluster and configure your sidecars. Have you ever tried something like this? Has anyone tried something like this?
Basically, like it's just a gut feeling with two patterns for that to work with an environment variables and check them on deployment. For example, if you don't know what deployment do you have, or in the AWS, for example, where the secret management key stores where you can just fetch stuff.
But I think it is part of those service measures to have a control plane.
So is there an Istio expert in the room? Otherwise I will not answer because I'm only a half-ass. Because Istio is more or less the control plane for the service mesh, and Envoy or other are the actual sidecar. So Istio is not the sidecar, Istio is the control plane, and it's the responsibility of the control plane to actually take care what the individual sidecars on the nodes do, and why Istio you do your load balancing, why Istio you configure who can see what, and why Istio you can then also introduce latencies and all those chaos experiments, and the sidecar just follows the signal of the control plane. Is that about right?
I think so.
Okay. So.
But that kind of introduces a problem, because when I have this remote function call, that's inside my container. So that maybe even customer submitted or something. And now I want to have a strategy on how this code is executed. And let's think about these retries and wait times and whatnot. So where does that come from? Is that also brought into the system from outside, or do I choose that? But I might not even know what this function does. I might not even know what's running inside the container, so how do I manage that?
Yeah, but you might do the configuration also with environment variables or with key stores and say, okay, for this in this case, timeouts, retries, etc.
And that should be transparent for your business.
So, of course, the fallacy of those remote calls is that you're hiding away everything, and the idea with the ambassador or sidecar pattern is to actually separate those two concerns. The one is concerned, I want to just execute something on a remote service, and the other one is responsible for making sure that you're reaching the right instance via the right protocol, and is doing all the infrastructure network heavy lifting. Okay. So you as a caller are taken off this burden, and of course then you lose some of the control you had previously.
Let's call this an execution strategy. So I want to have an execution strategy for a remote function call. But whose responsibility is that? Is that the responsibility of the guy who controls the control plane, the cluster, or is that the responsibility of the guy who implements the function?
The first one.
Of the control plane. But
your function should be agnostic of those topics.
With all the fallacy that come along with that design decision. If you don't want to have this kind of design, skip the ambassador pattern.
That was the example with the Python code in the beginning of the talk where we. Yeah, this was like the example. Yeah, you know, Walter told us, okay, the business layer should not deal with retries and stuff.
yeah.
Let this do the ambassador, the sidecar, the service mesh, and you as an operator of the whole system, you configure this. But you as a programmer for the business logic, you should not deal with this.
Yeah, that's not your concern as a programmer.
And if it's your concern, you have an abstraction and then you need to get rid of this abstraction. Or further questions? Ooh, yeah.
Some more hot pizza.
No, in the meantime, the pizza is cold. So there.
Just take a Yay! Woohoo! Ah, cool. So nice.
Okay, thank you very much, Walter, for the chaos and your resilience. And you are also a very resilient crowd. You're resilient against the heat and the technical problems we had in the beginning. And as a reward, there is still cold pizza and cold beer. And we can have another chat about what options we have for case engineering and what's the difference between the Chaos Kong and the Simian army and all of those things. So thank you very much. Have a nice evening.